Good afternoon, everyone. My name is Sergio Cabello-Leiva. I'm the soil scientist here in Carrington. So today I'm presenting can cover crops improve yields, mitigate salinity, and enhance nutrient cycling for corn, soybean, and sugarbeet in North Dakota. So there is several topics here, and I'm trying to cover them in a good way. So we have several issues, in any cropping system, and we are wondering how can we improve, like the lack of soil coverage that we see here. So nutrient losses because of this lack of soil coverage, runoff, wind erosion here in the northern plains, wind damage in our seedlings, and so on. So one of the options, and this is something that I want to be direct with you, these are just tools, either cover crops or no-till or minimum till, we gotta use them all. Sometimes some of them depends on our cropping system, soil conditions, farming equipment. Why when I use cover crop? Basically, one of the main point of view is like reduce soil erosion, decrease soil nitrate, decrease that nitrate that is about to leach into the soil, that out of our farming system, improve soil health, and this is related with all our previous presenters show us, related with like physical, soil physics, soil chemistry, soil biology, and prevents our seedlings for wind damage, which in sugar beet and in soybean could be important. Last year actually was important. And also one thing that I want to relate with the photo in the right, if you notice there, a lot of flowers. In this case, it's winter camelina, so it's habitat for pollinators, for beneficial insects, and etc. One thing is, can nitrogen in fall planted legume cover crops be credited to mice? So can we get those benefits direct to our crops? Like can we see the benefits for ours? So we have this research is published, so you can go over it, or you can contact me after and I can give you the paper, or we can talk about it and everything. So basically the methodology that we're trying to see if this nitrogen can be credited in corn is first of all to determine differences in cover crop biomass, nitrogen accumulation into the cover crop biomass, and to determine the differences in corn grain yield if we get some benefit direct in yield with different cover crops, legumes, and in this case, winter camelina, and different nitrogen treatments. So basically what we did was a wheat corn rotation, and in between, after we harvest wheat, we planted cover crops in August. That it's a normal window that we have here in North Dakota. I know in the West could be a little bit more challenging for the lack of water, but this is a very good opportunity to add cover crops and diversity to our cropping systems. So the cover crops that we were working here was basically fava bean, 4-HP here in the middle, and winter camelina, which was these three cover crops. Two of them are legumes, and this is a brassica. And then the next year, we planted corn over the cover crop residue. The only consideration, winter camelina is a winter hardy cover crop that survived pretty well the winter here in North Dakota. And as you know, winters here are something. This is my 9th season here, and still winters kind of remind me how cold it is. So the thing is, like, we terminated camelina, winter camelina. If you see here, it's kind of in flowering stage in around May 12, May 15. When we planted corn. So we terminated the same date of planting. And then we harvest corn. In this case, this photo, you can see the eyes there very late in the season. One of the things that I want to show you with these three cover crops, the units are in metric system, but for this case, like it's very similar than speak like in pounds per acre, like 0.8 if we transform in there. But for explaining you, I'm gonna try to make it very simple. Fava bean, you know, like the amount of biomass that you get in the cover crops between different seasons, it varies. Why it varies? Based on how much water we have in the system, how much rainfall we get, how good established those cover crops are, and how much like biomass we can get. In the case of fava bean, we can get around like almost 3,000 pounds per acre of dry biomass, and that could meet between 100 and 120, 130 pounds of nitrogen between August and October into the biomass. It's a lot of nitrogen that it's there trapped in that biomass. But again, if you compare with the following year in Hickson, for example, that could be reduced to half. And that's just biomass. That's just water. So how our management, how much of those credits we're going to see for, in this case, corn next year, it's going to depend. So there is a positive thing in case of winter camelina, the green bar. Winter camelina, all the nitrogen that you are seeing there is coming from the soil profile, because a winter camelina is a brassica, so they don't fixate nitrogen, right? So all the time they are scavenging there. One thing very important that we want to get with cover crops is green cover, you know, to protect the soil, a physical protection, a barrier to protect the soils against erosion. In this case, we reach around 60% of soil cover in 4HP. Okay, why is that? It's because if you see that in the photo, it's the prostrate growth. You have an excellent soil protection with 4HP, this case a legume. So moving on to the following season, you know, winter camelina was actively growing early in the spring. And this is the gravimetric water content early in the spring. The only thing that I want to show you from this BC graph is winter camelina decrease the gravimetric water content. Why? Because it was actively growing. Okay? Is there a problem? Well, if it is a rainy spring, that's not a problem. If it is a dry spring, for the cropping system that we're working, it could become a problem. Okay? And when, for example, Hickson 2019, it was like a very rainy spring. All cover crops, even camelina, they show the same amount of gravimetric water content because there is an excessive water. So what happened with our yield? Well, one thing, remember this experiment was in the Red River with high clay soils, you know, and we didn't terminate camelina until we planted. We did it on purpose because we thought it's not going to affect. But actually, if you see that in the red box, our grain yield was significantly affected compared with the legume and the check. So winter camelina did have a detrimental effect, a yield penalty, because the late termination. But also could be an opportunity for early termination or an early planting in a high clay soil, if water is a problem, right? But in this case, we got a yield penalty under the research standards that we were working, you know, and we gotta be consistent. These are 4 locations. So just to show you with the different, in this axis is the nitrogen rates, and here is the grain yield. Winter camelina is this line. Across all nitrogen rates, winter camelina performed significantly lower than the legumes and the check. So we got yield penalty with winter camelina. But with the legumes, we got a significantly higher yield, not significant, slightly higher yield. Why? My impressions in this research, we didn't get significant difference because this is a transitional no-till. So it was a conventional till soil that we convert into this. So there is the microbiome, like all that Carlos was explaining in the morning, I think needs to be adjusted. So it was a super harsh turn into soil terms, like goals, but it did affect our yield and we didn't see these benefits. But there is between 5 and 10 bushels of corn of benefit to having this. If I analyze them by a different location, I will find the differences. Overall, it's a mix of them. So cover crops in general, fava bean, 4-HP and winter camelina provided soil cover, protecting the soil from erosion. Average nitrogen accumulation was not different in fall, and cover crops did not decrease residual soil nitrate in late fall because legumes are not big scavengers, right? So they are fixing their own nitrogen. So the nitrogen that is leaching could be still prone to be lost. And winter camelina decreased yield in all nitrogen rates because of water use. Legume cover crops did not increase corn yields, but it's likely increase yield in the overall analysis. And there was no nitrogen cycling that I could tell you here. But because of what I mentioned, the problems that we have another research ongoing here in the center, supported by the Corn Council, which is basically cover crops and biological tillage to enhance corn yield and corn grain yield and mitigate soil compaction. If you see these two photos, in the left, you have a lot of green, right? That's Carrington. We have enough rain last year. And in the right, you have Minot. We didn't have much rain after August when we planted our cover crop. So again, this is highly related with how much water we have available, okay? So same thing here, in the left, these two graphs are Carrington, this is Minot. We have almost 5,000 pounds of dry biomass in oat mixes and legumes in Carrington. Green cover, excellent green cover. You saw that in the previous photo. But in Minot, we didn't get much biomass because of the lack of water. We got good germination, by the way. Very good cover crop establishment, but not biomass. But still, we achieved very good ground green cover compared with the Czech. The graph in the right bottom corner. So moving on to sugarbeet, do fall seed cover crops affect sugarbeet establishment, production, and nutrient cycling? Very similar that we saw in the other crop, but what happened in the other crop rotation, wheat, corn, this is wheat, sugarbeet. We have also this published in a Springer book. I also can give it to you if you need it, just contact me. And the objectives are very similar, determine differences in biomass, soil nitrate accumulation, and soil green cover, and determine the effects in yield and the yield components on sugarbeet. The methodology pretty much the same. We have wheat planting. We planted our cover crops after wheat in August, 2 locations. We have 6 cover crops. None of these are legumes because in sugarbeet, we don't want those nitrogen credits. We don't want excess of nitrogen because affect quality. So these objectives are different. So we have winter rye, winter camelina, winter wheat, all of them winter hardy. They should survive the winter. We have oat, radish, cool season cover crops, and the Czech without cover crop. Same thing, we establish the sugarbeet on May, and we harvest in October, September, depends of the year. Winter rye and winter wheat was terminated 2 weeks before planting, and winter camelina at planting date. So following that, let's see how much biomass do we get. So in terms of biomass, oat and radish in the fall, they are almost 2,000 pounds per acre of biomass. It's a lot of biomass. What happened with nitrogen accumulation into the biomass? Almost to 50 pounds of nitrogen. The beauty of these cover crops, they're all scavengers. So there is no legume here. All the nitrogen that you are seeing here, all these bars, the graph in the right, it's coming from our soil. So it's nitrogen that we are capturing and not letting it go free to the system. We are keeping it into the system. It's gonna be in the crops what we'll see, but at least we are not letting that nitrogen go away. From the environmental point of view, the sustainability is positive, but also I'm going to mention you, it's money that we are saving and eventually going to be available. We need to fine tune when it's going to be available and which is going to be our cash crop after. During the spring, the winter hardy cover crops were growing, so you can see a huge amount, almost 100 pounds of nitrogen per acre when you add the fall and the spring biomass. So basically the same amount of a legume. Imagine how much nitrogen we have there in our soils, prone to leaching when there's no catch crop. Plus the cover crop is going to protect against erosion too. So it's a win-win situation. Talking about like available nitrate in the soil, the blue bars is the fall. If you see there the check, when you don't have a cover crop, you have at least between 20 and 40% more available nitrate prone for leaching. Just to add in a cover crop, in this case, no legume cover crops, you're gonna prevent between 20 and 40% of nitrogen leaching. Again, it's gonna stay in your system. What happened in the spring? Something very similar. The winter hardy cover crops that were actively growing in the spring, winter rye, winter camelina, and winter wheat, they prevent that early nitrate available in the spring to leach. So what happened with soil green cover in fall? Oat, winter rye, and radish are the winners. You know, they really protect the soil, as you can see there in the photos. What happened with sugar beet next season? If you see these are very important. Remember, camelina in the left bottom corner was terminated until planting date, so we were at flower stage. And then you see the photo in the right where winter camelina and winter rye is, that's sugar beet population. So when we see a lot of yellow and red, we are missing sugar beet plants. And that, in the case of camelina, it's for early competition. And in the case of winter rye, it could be possible for certain allelopathy effect. What happened with the gravimetric water content? Same thing than the previous experiment. Winter rye and winter camelina, they really decrease our moisture early in the spring when we have a dry spring like in 2018. So something to consider. In this case, we didn't plant early, but if you are in a high clay soil or you have high water table, that could allow you to plant a little bit early or terminate your cover crops a little bit early. That one of the presenters said in the morning in the planting on green. What happened with the sugar beet population? Well, winter camelina really affected. I think it's not doable to leave it until planting date. We should terminate it a little bit early or plant it a little bit early, you know? And in the case of winter rye, it did have an effect, but sugar beet population is also super affected by the amount of rain, germination, you know? And remember, this soil is in transition and no-till. What about with root yield? Well, winter rye and winter camelina, it really decreased our sugar beet yield. But I could say it's not related with the amount of roots that we get. It is plant stand. Because of the early competition, we lost plants, so that is why we lost yield. Recovered sucrose, very similar picture, you know. We got some negative effect because of the early competition. But in the case of like the winter kill cover crops, there was no problem whatsoever. And even so, we saw some quality benefits here that I didn't present it here, but you can go to the presentation. Conclusions here, fall cover crops and soil cover were higher on radish and oat. Soil residual nitrate was higher in check plots. We have some gravimetric water content penalty because spring competition. And sugar beet and yield plant population was affected by winter hardy cover crops. They opened the possibility for early planting or controlling excess of moisture early in the season. So I could say it's not negative, but we gotta have some considerations. Another, how's my time going? I have like 5 minutes? I have 22 minutes. Well, I have 8 minutes based on the presentations. This is a very interesting research that we are doing here in the center, in Carrington, and supported by the North Dakota Soybean Council. Is mitigating salinity impact, spring planted cover crop boost soybean yields in North Dakota. This is published in the Carrington REC annual reports. I invite you to check those research. There's a lot of research, and previous year too, all our REC system has this kind of research available. And also it's published in the ASA meeting. So you can go there to ASA, look for my name, and you can listen the whole presentation of this research if you are interested. In North Dakota, salinity is a big issue. We have 1.9 million acres of salinity, so we cannot avoid it. It's there. And in the case of soybean, it's highly affected. Legumes generally, like dry beans, soybean, are generally affected by salinity. What can we do? We can use cover crop to reduce negative effect on salinity on the soil microbiome, activating what Carlos was mentioning in the morning. Water management to critical alleviate salinity, as we saw in the previous presentation. And using cover crop as a green mulch to prevent the excess of evaporation and get all that soil crust in our soils. So the hypothesis here is basically winter cover crops. Why we choose, you see in the photo there, you have winter rye, winter barley, and winter camelina. We're using winter cover crops, avoiding them to flower and bolting, when I keep them as a green mulch, okay? And to prevent the salinity problems. So it's a new concept that we are trying. The cover crops, I mentioned you, and also we have a mix, and we have 2 termination rates at R2 and no terminations, and seeding rates of 66 and 33%. Salinity is something very, very, very challenging. When I work in salinity, I never thought it was so difficult. So you gotta kind of scout the land and see how variable it is. One thing is producing, but also do research in a saline spot is something very challenging that I learned in the hard way. So we gotta map the area, characterize the area, and then if you see in the left corner the aerial photo, you can see how variable my soybeans ended up anyway. So one take-home note that I want to give it to you here, it's basically we got a yield benefit when we have cover crops in the 33% of the seeding rate, because we planted 1 month before soybean. So we got between 5 and 3 bushels extra. It's not significant yet, but we are seeing the benefit, but not terminating after R2. If you terminate your cover crop after R2 in soybean, you're gonna see a yield penalty. Okay, so we saw this benefit you see in the yellow arrows. We saw some benefits too in protein content with barley and camelina. We saw also some grain oil content benefits, but this is related to stress. Okay, so the plots with more stress, we got more oil basically because the plant wanna keep that extra fat there to face difficult times, And the conclusion of this study is winter barley cover crops with 33% of the rate yielded 7% higher than check plots. No termination later than R2, and we get some benefit in grain protein and also in oil. So this project is still working. We have it this season again, and I invite you for next year to check the annual reports, or you are welcome anytime here. Some take-home notes. I know my time is kind of running. Based on my presentations, I have 2 minutes. Cover crop provides soil protection from wind erosion, water erosion, runoff. It depends if you have hills or not in your soil. They could prevent, soil compaction and those kind of things. Decrease nitrate leaching. That's a big win of cover crops here in the state. So any cover crop that you plant after wheat or any kind of cereal grain, you're gonna prevent nitrate leaching. Some consideration: winter hardy cover crops can compete early in the spring, and most likely, if that spring is dry, it could give you a yield penalty in your cash crop. And cover crops can potentially mitigate salinity issues related to high EC and excess of moisture here in the state. And cover crops can be used as a green cover too, and it depends on the mix, or depends on the salinity problems, to prevent the soil crust in the top. Some online tools that I want to mention just to you. There is a lot of online tools related for the Northern Great Plains. One tool that I really like is the Cover Crop Decision tool from the Midwest Cover Crop Council. And you can enter there your cropping system, what are your goals, which is your catch crop, and it gives you here in the right, you can see which cover crops you can plant there. So I can give you later all this information. It's all free. It's very useful. Well, thank you to the North Dakota Soybean Council, to the North Dakota Corn Council, ANIT, the Agencia Nacional de Investigación y Desarrollo from Chile that support part of this research, NDSU Carrington personnel. And this is my professional information. I'll be happy to try to answer your question. It's a lot of information. I was trying to show you the good, the not so good, and the bad of cover crops, but it's something that we have to work. I think when we add cover crops in our cropping system, we gotta start thinking differently. I think they are a great tool. We can achieve great things, but we gotta think differently.